So we've taken a look at simulating these tentacles with vellum soft bodies, but we can also simulate these with curves or vellum hairs, which are essentially synonymous in this case. And to do that, we can leverage the curves that we've already created in the general creature setup. So I'm going to follow this object merge, which is currently linked to object creature out creature. And let's jump over to that. And let's find the curves that we originally set up for our procedural modeling on these tentacles. And here we go. We've got these out tentacle curves here. And we can just simulate these lines directly, which can avoid a lot of the difficulties that we're encountering when simulating with cloth or soft bodies. If we go back to the soft body version here, these are fairly complex collisions and volume enforcing constraints and etc. that vellum has to handle. So just simulating these as curves that have an inherent thickness to them can potentially allow them to bend more freely and can simplify some of these collisions. And in cases like this where it makes sense to represent an object as a curve with thickness, this can be a really good option instead of simulating it as cloth or soft bodies. So let's start by object merging in those lines. So I'll create a new object merge and I'll point that to object, creature, out tentacle curves, and display that. And similar to before, we're going to set up a pin group for this. Let's display the points for these curves. And if we middle mouse on this object merge, then we can see what the values are for the x-axis, which is what the curves are pointing down. So it looks like the minimum x value of these curves is 14.07. So we can use that to just group the endpoints for our pin group. So I'm going to drop in a group expression after this object merge. And on this group expression, I'll set the group name to pin. Group type will be points. And for the vexpression, I'll say at p.x is less than 15 and display the group expression. And you can see that with the value of 15 and x, that's grouping the 2 points at the start of the tentacles here. So I'm going to start by just pinning the very first point here. And once we start applying this simulation on the actual creature model, then we can decide if we want to perhaps pin a couple more points in place in addition to the very root one. But just to start with the root, let's set this p.x threshold to 14.5. That'll give us just the very first point there. And now type in vellum configure, and we'll select vellum configure hair. Now connect our group expression with the pin to our vellum hair. Scroll down to pin to animation, and let's select our pin group for that. And I'm going to start by leaving all of the default settings on this, and as before, we're going to copy our vellum solver from either the cloth or the soft body version. So let's just copy that because that conveniently has our existing setup for the noisy wind and everything. And then, similar to what we did with the cloth and the soft bodies, we'll take the first output for the vellum hair, put that into the first input of our DOPNet, and the second output of the vellum hair, as we've seen before, is going to be the constraints for those hairs, which doesn't really look much different in the viewport. Looking at the first output of vellum hair compared to the second is kind of visually the same thing, but in one we have the actual hair polygons themselves, the other output represents the constraints, and the attributes do differ between them. You can see that on the vellum hair first output, this is largely defined by point attributes on that mesh, whereas the second output for the hair constraints is mainly driven by these primitive attributes here. So let's connect those constraints to the second input of the vellum solver and rename this to hair curves. And let's see what results we get with the default hair settings here. So now after flipbooking our curve simulation, you can see we're getting some results that are kind of similar to what we saw with the cloth and the soft bodies, since we're using the same pop wind turbulent setup for this, but this is behaving a bit more erratically because we don't have so many cloth and soft body constraints that are holding this all together, and this is likely using a very tiny collision threshold for all of these curves. So we can do a few things here, and we can start to add some collision thickness to these curves and potentially add some drag and such to calm this down overall. We could also try adding in some density to make these curves a whole lot heavier. And there's also a little bit of weirdness here on this one particular curve right in here. And this makes it look like we may have two curves stacked up on top of each other. So this issue where we have, it looks like one single curve here, but it's kind of splitting apart there. That looks like a bit of a problematic thing that we may need to debug with our actual curve source. So taking a look at our object merge, let's look into that one first, and let's display the hair curves and zoom in just on that problem point there. It certainly does look like we have two curves just lined up on top of themselves. And one way to check this is if we just display this object merge and then go into point selection mode and just grab one of these points here, hit T to go into that transform edit mode, and sure enough, it looks like we have two curves doubled up there. So let's delete that edit SOP that we just made, and let's go back to our tentacle curves and fix this apparent issue. And the reason for this is likely because this circle has a start and end point landing at the same point here. So essentially this circle is not only going to have a single point at all of these little peaks that we see here, wherever the curve starts and ends. This may be visible if we turn on point numbers here. Yeah, you can see we have point numbers starting at 0 at this point here. It might be a little bit hard to see in the screen capture, but it goes 0, 1, and so on. So we have point 0 and point 12, both at the very same start and end point here. So one way that we can fix this is to simply delete one of those points. After our circle SOP here, I'm going to drop in a blast. Then I'm just going to put in the number 0 to delete the very first point. And for the group type, I'll set this to points. And if we display that, you'll see that's eliminating that very first point there, so that we only have the points at the very peaks of this circular polygon. So bypassing the blast, you see we have a complete circle here with that duplicated point, and now we have this gap here. But that little gap is not really a problem at all, because we're just essentially using this circle to generate some points that we're copying our lines onto. So now that we've fixed that, that should eliminate any doubling up of those lines there. We can turn off our point numbers and go back to our hair curve simulation setup. And if we display the Vellum solver here, where we're seeing that apparent issue, currently we still have the old simulation saved in memory here, but if you zoom in on that problem area and on the Vellum solver, let's hit reset simulation. And now you can see that that problem's gone away, and we now just have that one single curve instead of two landing right on top of each other. And then in order to set the correct thickness for these curves, let's template display the creature that we've already object merged in for the cloth and soft body simulation. And if you look at the collision thickness that these curves are using, you can see that's much more narrow than the tentacles actually are. So if you line this up so we can get a good look at the collision thickness of these curves relative to the tentacles, and then go back to our Vellum hair SOP, we can start to increase our edge length scale to thicken up that collision so that the thickness of the curves more or less matches the thickness of the tentacles. And you can have this slightly larger or smaller than the tentacles, depending on if you want to give yourself a little bit of collision buffer. So with that edge length set up, let's once again rewind our simulation and display the Vellum Solver output. We'll get rid of our creature template display and do a new flipbook and see what our new curve simulation looks like. And this tentacle curve simulation looks like it's all working properly, but there's a lot we can do to improve the behavior of this simulation, and it's also a bit difficult to judge how this is working just by looking at these curves without seeing this applied to the actual creature mesh itself. So in the next video, we'll take a look at finessing the simulation and adding a whole bunch of different ways of controlling the behavior, and we'll apply the simulation to the actual creature model itself.